Hello, this is question 6 on your November 2021 paper from a statistics paper from edexcel, and it's a question that looks more difficult than it is. So you have discrete random variable x has this probability distribution. So the probability of x being a is log to the base 36 of a, and the same with b and c. A, b, and c are integers, and a is smaller than b and smaller than c. They are all different, and all the probabilities are greater than 0. Find the value of a, b, and c. So we know that the probabilities in a probability distribution must add up to 1. So one thing that we can write about those probabilities is, so for a, that log to the base 36 of a plus log b plus log c, 36 c must be 1. If we use the properties of the logs and they have the same base, we have this. Yeah, remember the sum of the logs is the log of the product. And then if we have the log to the base 36 of ABC equals to 1, that means that ABC is going to be 36. Now we have 3 integers. They are all different, and the product is 36. So if we write 36 as a product of prime numbers, we have is 2 squared times 3 squared. So the possibilities are just, there is only one possibility, which is having these separate, so 2, then a 3 separate, and the product of these 2. So we can write this as product of 2 times 6 times 3, yeah? Combining 1 2 from here and 1 3 from here to get the 6. So these are your numbers, yeah? Their numbers in order could be 2, I'm going to write which one is which one. So A is the smallest, A is the smallest, then B, then C. So A will be 2, A will be 2, B will be 3, and C will be 6. Yeah, and that's the first part. Yes, it's just scary when you see it, because you see these probabilities with logs, but it's quite simple. And then the independent random variables x1 and x2 each have the same distribution as x. We have to find the probability that x1 is equal to x2. So now that we know A, we know these values here and these probabilities, because we can find the logs. We have a second variable, x2, that is exactly the same. So we will have another table like this one. And we want the probability that x is in both cases A, or in both cases B, or in both cases C. So the probability of x1, so if we can call this x1, we will have again an x2, and it will be exactly the same, which means probability of them being equal is both being A, or both being B, or both being C. And we can write that as probability of x1 equals x2 would be probability of both being A would be this probability squared. Yeah, or remember when you have or, you write plus. Probability of both being B is this one, is the product of both being B, or probability of both being C. Yeah, it's like when you have the probability of being, when you roll 2 dice and you say the probability of being get to 6, to 5s, for example, it will be 1 6 times 1 6. Yeah, so this is quite similar. And then we just have to find the values with the calculator. So we know A is 2, so log to the base 36 of 2 squared is, I can give you the values, 0.0374. The next one squared is 0.0939, and the next one squared is 0.25. When you add them all together, you have something like this, and you can round. They don't say anything. So let's say 3 significant figures, which is a good rounding. 2, 3 significant figures. I would keep the values in the calculator, yeah? So add them to the memory or just write the whole expression all together, but don't round too early, yeah? You get this value and then you round at the end. Because if you round these values, you may lose some accuracy, yeah? And that's all with this question.